This is the review video for the IB Math Studies Final Exam Fall Study Guide. So starting with the paper 1 questions, number 1 is from topic number 2, one variable statistics. So they give us 10 resting pulse rates, and part A wants us to find the median. So first thing is always write them in order from smallest to biggest, and then the median is the middle number. In this case, there's an even number. So halfway through is between 63 and 65. So if you take the average of those two, you get 64. So the median is 64. The mean, you add all of these up and divide by the total, how many there are. So if you add them all up, you get 639 divided by the 10 different ones. So the mean is 63.9. You could have also done this on your graphing calculator if you had put these data points into list 1 and then gone into one variable statistics. It would have given you your mean, or X bar, and then also given you, if you had scrolled down, your 5-number summary, which includes your median. Part C says that another student joins the group, making it a class of 11, when now the mean is 65. So this is knowing that if you add them all up and divide by the total number, you get the mean. So we have 639, the total from above, plus this new one we don't know, divided by 11 is equal to the average of 65. So multiply both sides by 11, you get 639 plus x equals 715. Subtract 639 from both sides, you get that student's heart rate was 76. Number 2 is a topic 4 question, which was your 2 variable statistics. This was lines of best fit. So they give us some data. We know this is 2 variables because it's giving us 2 different things we're comparing: time walking x and calories y. So those are 2 different things. So this is going to be 2 variable statistics. On this one, they wanted us to find our line of best fit. So you enter your x coordinates as list 1 and your y coordinates as list 2. And then you go into stat calc line regression, which is number 4. And you get y equals 14.9x minus 80. Part B wants us to use that equation to estimate the number of calories someone will burn by walking 17 minutes. Well, minutes is your x coordinate, so I'm going to plug 17 in for x in the equation we found above, and you get 173.3 calories. If you round to 3 significant figures, that's 173 calories. Part C wants to know if it's reliable, so this is asking about correlation coefficient. Your calculator, if it's you have to turn on correlation coefficient, but if you do, you get R to be 0.989. Remember, the closer to 1 or -1 means the higher correlation. So this is reliable because you have such a high correlation coefficient. And you have to have your correlation coefficient in here to get the points for this one. Number 3 is a topic 2 question again, because we're back to one variable statistics. We're talking about children with dental fillings. The reason I know it's one variable stats is because this column is, or excuse me, this row is number of fillings, and this is just frequency. So this isn't a second variable, it's just how many times this number occurs, this top number occurs. So 0 happened 4 times, 1 happened 3 times, but the only variable is fillings. So this is one variable stats. So part A asks you, what is Q? Well, we know there's 25 total students, or 25 total children. So if you add all these up, it has to be equal to 25. So if you add them all up, you end up with Q plus 20 equals 25. So that means Q is equal to 5. Now we want to use our graphing calculator for part B. So you go into stat, edit, and you put list 1 is your number of fillings, and list 2 is your frequency, including 5 for Q. And then you go into stat, edit, one variable statistics. Make sure you tell your calculator that you have a frequency table, a frequency list of list 2. So then you get your x bar, or your mean, to be 2.2. If you scroll down in your 5-number summary, it tells you that your median is 2. And then your standard deviation, they give you this whole long number, which if you round to 3 significant figures is 1.39. Number 4 is topic 4. So we're talking about normal curves and the height of apple trees being normally distributed. So this is the notation for normal distribution. Remember, x is normally distributed with a mean of 3.42 meters and a standard deviation of 0.21 meters. That's a little squared up there. That's just how we write it out. So the first one is only worth 1 point, so your normal curve won't actually give you any partial credit on this one, because it's just testing that you know that to be greater than or less than your mean is 50% of your data. So if you are greater than 3.42, which is our mean, then that's 50% of the data. You could have also done this in your calculator if you didn't remember that, but that's just testing that you know that. Similarly with part B, it's only worth 1 point, so your standard deviation or your normal curve wouldn't give you any points on this one, but they're testing that you know basically the rule, the 50, 67, 95% rule. If you're within one standard deviation, it's 67% of your data. If you're within 2 standard deviations, it's 95% of your data. And if you're within 3 standard deviations, it's 99% of your data. So 95% of your data falls within 2 standard deviations of the mean. Part C. So they want to know what the probability that a randomly chosen tree will have a height greater than 3.35 meters. So you always want to draw your normal curve first. 3.35 is smaller than your mean of 3.42, but we want greater than, so we're going to shade to the right. So we want to know the probability that x is greater than 3.35. So we go into second variables, which is distribution, and we want normal CDF. Your lower bound is the smallest it can be, which is 3.35. Your upper bound in this case is infinity, so we rewrite 1e99. Your mean is 3.42, and your standard deviation is 0.21. So they give you this value, which is 0.631 or 63.1%. Part D says that the probability of a randomly chosen tree being less than some x meters high is 65%. So the probability that x is less than x is 65%. So we draw our little curve here. We want it to be a less than, so we're going to shade to the left, but we want our tree to have a higher than 50% probability. So to be higher than 50%, we need to shade over the mean, so that means our x value needs to be to the right of the mean. So this is what your normal curve should look like. This would give you 1 partial credit point. So then you go into second distribution, and you want number 3, which is inverse normal. Your area is 0.65, and then your mean and your standard deviation. You get that a tree, the probability that a tree is less than 3.50 meters high is 65%. For part D, remember that your calculator will only do a less than on these. So if you're given a greater than problem, you have to change it and do the 1 minus whatever they give you to create it and be a less than problem. Number 5 is a topic 1 problem. So you want to evaluate this 17x squared over a minus b, given that x is 12.5, a is 0.572, and b is 0.447. So plugging all of that into your calculator, make sure you either do it in separate parts or you put parentheses around the denominator. You end up with 21,250. Part B, number 1 wants you to round to the nearest 1,000. So here's our 1,000th place. This is less than 5, so it's going to just be 21,000. Part B2 wants us to go 3 significant figures. So remember, trailing zeros are not significant, so I'm going to round up from this 5, and so you get 21,300. Part C wants us to put it in standard form or scientific notation. So that means that the number in front it has to be between 1 and 9. It can't be 10, it can't be 2 digits. So that's going to go down to the 2, and then everything else behind it becomes a decimal, so 2.13. And then we moved our decimal place over 1, 2, 3, 4 spots, and we made it smaller, so that means this is going to be a positive 4 up there. Number 6 is also a topic 1 problem, but now we're talking about sequences. Specifically, this one is geometric. I know it's geometric because it's talking about a percentage more than the day before, so that's going to tip you off that it is a geometric sequence instead of an arithmetic. If he runs 10% more every day, that means he runs 110% of what he did the day before. So your common ratio is 1.1. So if you want to find out how much he runs on the second day, it's 1.5 that he ran on the first day times 1.1. So he runs 1.65 kilometers on the second day. Part B wants us to do the total he'll run after 7 days. So you can use your geometric sum formula. So your first term times your ratio to the nth power, in this case 7, minus 1 over your common ratio minus 1, which gives you this. You could also use your summation notation and use the sequence sum formula in your calculator. Either way, you should get, rounded to 3 decimal places, 14.2 kilometers. Part C, you will need to use your summation formula or keep adding up until you get to what you need. So I set up the summation formula, the first term 1.5 times the common ratio 1.1 to the nth power, because we don't know how many days it is, minus 1 over 1.1 minus 1, and we want that to equal 100. So in my graphing calculator, I made this y1. Make sure you either put parentheses around the denominator or simplify this down to 0.1. And then I made 100 y2, and I found where they intersected. They intersected at 21.371085, but he's not running partial days. So that means after the 22nd day, he's hit that 100 mark. Number 7 is topic 5, the equations, linear equations part of it, the geometry part. So the first question, it gives you a line 2x plus 5y is equal to negative 4. I want you to find the slope of that line. So I put it into slope-intercept form, y equals mx plus c. So you subtract 2x from both sides and then divide by 5. So your slope's whatever is multiplied by x. It's just the number. Don't include x with it. It's just negative 2/5. And then your second line is perpendicular. Well, perpendicular is opposite reciprocal, so if we want the gradient of it, you're going to flip it over and change the sign so it becomes 5 over 2. Now it tells us that the 0.53 is on this line, L2, and they want us to give the equation of the L2. The easiest way to do this, if they don't tell you a specific form, is to put it in point-slope form. So y minus the y coordinate is equal to slope x minus the x coordinate. So y minus 3 equals 5 halves x minus 5. A lot of times they'll tell you to put it in slope-intercept form, so solving for y. So distribute your 5 halves and then add 3 to both sides. You get y equals 5 halves x minus 19 over 2. And then every once in a while it'll ask you to put it in standard form, so clear out the denominator, which is multiply everything by 2, and you get negative 5x plus 2y equals negative 19. Since this one didn't specify, any of these three are correct. Part D says using your graphing calculator or otherwise, find the intersection point. So if you were using your graphing calculator, you would put 5 halves x minus 19 halves into y1, negative 2/5 x minus 4/5 into y2, and then find where they intersect. Otherwise, you can solve by substitution like I did here, or if you had them both in standard form, you could solve using elimination. Either way, you should get 3 comma negative 2. So now we're getting into the paper 2 questions, the longer ones. So number 1 is a topic 2 question because we are looking at frequency of one variable happening, something with one variable, just the car's speed. So part A, so they give us this cumulative frequency graph, and then we're going to read information out of this. So part A asks us for the possible minimum speed. So you can see the cumulative frequency graph kind of starts right here at 10 kilometers per hour. So part A would be 10 kilometers per hour. Part B asks us to find the median speed. So median happens halfway through your data. So if we have 120 data points, that means the median occurs at the 60th. So I follow the 60 line across. Wherever it hit the cumulative frequency graph, I went straight down. And you get it to be about 36, 35.5, somewhere right around there, kilometers per hour. Obviously, you should be using a ruler for this. It would make it a little bit more accurate. Part C asks for the 75th percentile, so that's 75% of the way through your data. So that'd be at after 90 cars. So you're going to do the same thing, follow it across. Once it hits your graph, you follow it down. And again, somewhere around 41.5, between kind of 40.5 and 42-ish. So I said 41 kilometers per hour. Your interquartile range is your Q3 minus your Q1, so your 75th percentile minus your 25th percentile. We already found our 75th percentile, so that was 41. So we need to find our 25th, which is when after 30 cars. So you go across, and I found it to be about 31. So your IQR, the distance of your box on your box and whisker plot, if you were to do one, would be 10. Part E asks the number of cars that are going to exceed the speed limit if the speed limit is 50 kilometers per hour. So in this time I started at the kilometers per hour 50 and went up and then went across and found that 110 cars are less than 50 kilometers per hour, which means 10 cars are speeding. They're going over 50 kilometers per hour. So that's how on part E I got 10 cars. So now moving on, they give us a frequency table with the speed of the vehicles broken into groups of 10. And for part F, they want us to find our missing frequencies, P and Q. So looking at the table, if you go to 20 vehicles and you see how many cars they've done, the frequency, similar to what we did for part E, you get that P is 4. And then Q, we found how many cars are above 50 kilometers per hour right here. It was 10, so Q is going to be 10. Part G, so one single I is asking for the modal class. Modal is the most. So right here I see that there were 64 cars between 30 and 40 kilometers per hour, and that was the most. So that's our modal class. And then our mid-interval for that class is just the midpoint for that class. So in that case, it's 35. So they are asking you to do this to lead you into part H. So part H, we want to use a graphing calculator to find the mean and the standard deviation. So this is one variable statistics. We're just looking at frequency versus speed. So because these are not single numbers, they're groups, you have to find the mid-intervals of all of these. So L1 is going to be your mid-intervals of your speed, so 5, 15, 25, 35, 45, and 55. And L2 is going to be your frequency. So then you go into stat and one variable statistics. Make sure you tell your calculator you have a frequency list as L2. And then calculate, you get that your mean is 36.833333 on forever, or 36.8 rounded to 3 significant figures. And then your standard deviation is this whole long thing rounded to 3 significant figures would be 8.85. For the last part, they're thinking about lowering the speed limit to 40 kilometers per hour, and they want to know the percentage of cars that would now be speeding. So you want to look at the cars that are not currently speeding. So 10 cars were already speeding, so that means 110 are currently not speeding. And 26, if you look up here between 40 and 50, would now be speeding. So 26 out of the 110 that are currently not speeding would now be speeding, and that would be 23.6%. Number 2 is two variable statistics. It's chi-squared test, so it's topic number 4. So they give us a data table with fertilizer type versus the yield, the crop yield that they found. And they want to know whether the fertilizer type had a significant impact on the yield. So we want to test at a 1% significance level, so that would be an alpha being 0.01. Part A wants us to state the null hypothesis. So null is always independent, so yield is independent of the type of fertilizer. Part B wants us to find the degrees of freedom. So that's your rows minus 1 times your column minus 1, so 2 times 2 is 4. And then part C wants us to show that the expected frequency is 17 for medium yield fertilizer C. So I found medium yield fertilizer C, and we find expected value by your row total times your column total divided by your total. So 50 times 40 divided by 120, which ends up being 16.66667, which is, if you round to the nearest integer, 17. Part D, you're going to use your graphing calculator. So you go into matrix. In this case, we want a 3x3 matrix. Put in all your data, and then go into stat tests, and we want to find the chi-squared test, not the GOF, just the regular one. And you find that your chi-squared statistic is rounded to 3 decimal places, 3.86, and your p-value rounded to 3 significant figures is 0.425. So then part E, we want to know whether or not we should accept or reject our null hypothesis. So that goes back to the fact that we have an alpha level of 0.01, and we found our p-value to be 0.425. So 0.425 is greater than 0.01. Our p-value is greater than our alpha level. So we do not reject the null hypothesis. Think of p being petite. We always want it to be smaller to reject our null hypothesis. In this case, it's bigger, so we do not reject. The yield is independent of the fertilizer. Problem number 3 is a topic 1 problem. It's dealing with sequences and arithmetic and geometric sequences and then financial maths. So we're given options for Vera's 18th birthday of her allowance that she gets to choose from. So part A wants us to know how much money she will have after 2 years if she chooses option A, where she just gets $100 a month every month for the 2 years. So 100 times 24, she would have $2,400 at the end of the 2 years. Part B is a fixed amount, that $1,100 that she puts into a bank account that gives her 12% per year, compounded monthly. So we use our compounded equation. So your initial value or your current value, and then your interest rate divided by 100 times how many times a year it's being compounded. If it's being compounded monthly, it's 12 times a year. Raised to the how many times a year it's compounded times how many years, so 12 times 2. You could also use your financial apps on your graphing calculator. Your current value, make sure you make it negative 1100 for your graphing calculator. Your R, your compounded per year, or C per year, and then your N. Either way, when you find your future value, you get that she would have $1,397. Note that it tells you to round to the nearest dollar on all of these. Option C is an arithmetic equation. She starts with $75 and gets $5 every month, or $5 extra every month. So in the 9th month, she'd have 75 plus 5, her initial value, plus her common difference, times n minus 1, or 9 minus 1. She would get $120 on the 9th month. And then how much money total she'd have after 2 years. You could either use your summation notation in your graphing calculator or the arithmetic sum formula. We don't know how much she gets on the 24th month, so I'm going to use the one where you don't know. So your n divided by 2 times your initial value plus your common difference, n minus 1, and she would have $3,180. Option D is geometric, with an initial value of $80 and a common ratio of 1.05, because you're getting 105% of what you got the month before. Remember, if you're ever increasing, you always have to add that 1 in front of your common ratio. So how much money she'll receive on the 14th month? So your initial value times your common ratio raised to the n minus 1 power, she would get $151 on the 14th month. And then how much total she'd get in the 2-year period. You can either use your sum formula in your graphing calculator or your actual geometric sum. Your initial value times your common ratio raised to the nth power minus 1 over your common ratio minus 1, and she would have $3,560 at the end of the 2 years. So then which one would give her the most money? This one is the highest value, so at the end of the 2 years it would have the most money. So option D would be the one that would give her the most money after 2 years. And then part F, she wants to invest $1,200 in a bank, and that's compounded annually. And on her 22nd birthday, so 2 years later, she wants to buy a scooter for $1,452. And what interest rate does the bank have to offer her to allow her to buy this scooter? So you know your future value and you know your initial value or your previous value. We don't know R. Divided by 100, it's only compounded one time a year because it's annually. Same thing here, but it is, again, 2 years. So you can either solve this, divide by 1200, square root both sides, and solve for R, or you can use your financial apps on your calculator. Either way, you end up with R has to be 10%. So the last one, number 4, is a topic 5 problem, the geometry, trigonometry that we were just working on. So they give us this diagram and they tell us the pieces of information, and she decides she wants to sell this portion over here, ABD. So first she builds a fence from B to D, and we need to know how long that is. Well, we have a side angle side triangle over here, so that is law of cosine. So I'm going to use the law of cosines to find this side C. So C squared equals 190 squared plus 120 squared minus 2 times 190 times 120, cosine of 75 degrees. Make sure your calculator is in degree mode. So plug this in your calculator and then take the square root, and you end up rounded to 3 significant figures, 197 meters. Part B tells us that the cost of the fence is $17 per meter. So we want to know how much the whole fence is going to cost, rounded to the nearest dollar. So 197 times 17, it's going to cost $3,349. Part C wants us to show that the angle ABD is 18.8 degrees to 3 significant figures. So we know this side C now, so we have an angle side triangle, which means we have a law of sines triangle. So we have 70 over the sine of this angle B is equal to 197 over the sine of 115 degrees. So cross multiply, and then take the inverse, divide both sides by 197, And then we're trying to find for the angle, so we need inverse trig. So B is equal to sine inverse of 70 times sine of 115 degrees divided by 197, which is 18.7862375, which is 18.8 to 3 significant figures. You do need to show this non-rounded version to get the full points. Part D wants us to find the the area of triangle ABD. So we have a formula for area of a triangle, which is 1/2 AB sine C, which is 2 sides and the included angle. So we know these two sides here. We know AD and BD. So we need this angle D in here. We have two of the angles, and we know all three angles in a triangle add up to 180 degrees. So we can find that this angle D is 46.2 degrees. So once we've done that, we can use our formula for the area of a triangle, which is 1/2 the two sides times sine of the included angle. So 1/2 70 times 197 times the sine of 46.2. And rounded to 3 significant figures, you have 4,980 meters squared. Make sure you have your units on here. Similarly to part B, she tells us that she's going to sell the land for $120 per square meter. So we multiply what we found in part D times 120, and you get $597,600. She then invests $300,000 of that, and she wants it to double in 15 years, and what interest rate would be required for that to happen. So for it to double, that means that she's going to have $600,000 equals $300,000, 1 plus R, we don't know, over 100, it's compounded annually, so K is 1, raised to the 1 times N is 15. So you can either calculate this, divide both sides by 300,000, take the 15th root and calculate R by that way, or you can use your TVM solver on your graphing calculator and you end up with 4.73%. So this has been the final exam review video. If you can do this review guide well, you should be able to do the final exam well. So make sure you understand how to do all of these problems and know where to find everything on your formula booklet, and you should be very successful on the final exam.